The hallmarks of Alzheimer's are the amyloid plaques and the neurofibrillary tangles, but there was always a search for non-fibrillar protein aggregates, and recently these smaller oligomers or non-fibrillar aggregates from different proteins have been implicated in the disease's pathophysiology. And the reason for it, they are more active. So they are small, they can be transported from cell to cell. Also, they can bind to receptors or other proteins. They are kind of sticky more than the fibrils. And having said that, the dynamic relationship between fibrillar aggregates and non-fibrillar aggregates, oligomers or protofibrils, still poorly understood. So there is a dynamic relationship. And by dynamic relationship, I don't mean equilibrium. I mean, sometimes the fibrillar aggregates like almost neutralize these small aggregates, and perhaps at later stage, they could be a reservoir for these aggregates. So it's pretty clear that these oligomers, and people looked for them for a long time. And recently, many labs call them oligomers or high molecular weight aggregates. They're pretty well studied, I would say, right now. The weakness is that unlike the fibrillar tau aggregates, which now we have cryo-EM structures, for these oligomers or non-fibrillar have atomic structure, and also we don't have reliable assays for quantification. First of all, with tau, some people, or including us, we used to prepare recombinant tau aggregated in the test tube and do cells in vitro or in cell culture, etc. But then once we have the reagents, we were able to isolate both the fibrils and the soluble oligomers from the same Alzheimer brain, and then treat cells, primary neurons, brain slices. Even we injected them into animals, and we published this like I think 2012. And only the oligomers spread the pathology throughout the brain and cause memory deficits. However, the large fibrils did not. I have to make a distinction that if you chop these large fibrils into smaller pieces, they become active also. So, and one thing I missed to say about these oligomers, that in many of the tau transgenic animals, the synaptic dysfunction and phenotypes actually appeared before these large fibrillar aggregates deposit in the brain of these animal models. So that was also a strong evidence for it. The good news, at least in the US, is funding what they call them networks. So we have a network to basically in a year or 2 years to be able to a cross-lab characterization of these oligomers. Hopefully, we will solve also the atomic structures, then have them available for free for other scientists to do more work. So I think that's a great approach, because reproducibility is hard, and sometimes, you know, you have to have a collaborative network which verifies and distributes. So when other labs use the same preparation, you know, we can compare results, and this is good for any kind of research. But for amyloid or tau aggregation specifically, it's critical, because these are dynamic structures. So if we don't establish their stability, their characteristics, and it should not be reagent dependent or lab dependent, it should be straightforward. And I think the community is getting together, and it's really exciting. So we're very optimistic.